That was, yeah.
Fake stuff.
Whenever people were referencing certain mathematics, I'd look up the book and tell them. I'd be like, well, actually, reread the section, refamiliarize, and then I
Technically, this is not historical.
Yeah.
Okay, so. Let's.
Question.
What class? Yeah, hurry up. What?
So for our live text developing portfolios, do you know how to take a live text document and put it into another one?
Yes. And I don't know why they don't make it clear, because this is it's just look for the live text symbol, that little ditty. Okay, actually I think it's the old one. I think it looks like this. I think.
Okay.
In there, in the text editor, when you want to like there's a link. It's either there's a link, you know, your typical link, and then beside that I think it's a link with a live text editor beside it.
Okay.
Look for that. I mean I don't want to do it right now because we don't have a whole lot of time, but
That's fine.
on Thursday at the very beginning, remind me if you haven't figured it out, and I will do that.
Gotcha.
Okay, so this class, today's objectives, I want you to be able to walk out of here and state my 3 axioms for teaching, which hopefully you've heard them before. But then we're just gonna have a little discussion today about what is meant by pedagogical content knowledge, because that's the name of the course, right? PCK, pedagogical content knowledge. What the heck is it? Explain what's meant by examining secondary content from an advanced perspective. So that's what that's what we really want to do, because this course is about, and again, it's just a seminar class, it's 1 credit. You know, we come in and chit chat for 2 hours a week for half the semester, and we really take concepts. This class is more about concepts, and we say, let's make sure we understand what that is. Like the first concept really is going to be parallelism. Do you really understand the concept of parallelism? I don't know. I mean, I might say right there, well, how's this? I know you know those are parallel, right? Those parallel? I don't know. Is a line parallel to itself? A student asked me that one day. And I was like, I don't know. And I had to figure it out. I know the answer now. And that's what we're gonna do. We're gonna perform these concept analyses and that. And so, you know, the homework that you have in here is to go and look at my next concept and not do a whole lot with it, because you can't. You don't really know where it's all going because you've never looked at it this way before. So you just look at it and think about all you know about it. And I tell you, I actually put some high school books on reserve. Okay, not the library. In the Smart Center, the room to the left, it's unlocked. And when you open up that room, right there's a bookshelf. Okay, and I just put a couple geometry, algebra books and that. If you don't have a textbook, like a high school textbook, go in there during time, and there are some dictionaries in there too. Everybody needs a good math dictionary. Ask for that for Christmas next year, okay? But a good math dictionary. I know you can go online, and I know you'll do a lot with the internet, and that's fine, but you need some textbooks too, okay? You need a textbook that you can always leave through. Leave them in there, do some work in the Smart Center or whatever. I guess technically you can take one, because there's only 4 of you. You can take one back or take one. But you're not really gonna want one. You're gonna wanna look at things in 3 different books, and then things online as well. But anyway, that's what we want to do. And I really want us to appreciate the need for pedagogical content knowledge in order to create and implement high quality learning experiences for adolescents, and use PCK to create high quality learning experiences. And use it. So appreciate it and use it. As I look at my career, it's my 26th year of teaching, and the reasons that I have. The reasons that I know, well, I don't want to say reasons, I probably want to say reason, there's probably only one. The reason, well, I'll give myself to that. The reasons that I know things deeper today than I knew 20 years ago are probably twofold. First one is because my stinking students ask me flipping questions that I don't know the answer to, okay? And you'll probably, now they don't ask me as many questions that I don't know the answer to, because I've thought about the answers and been asked a lot of them, but everyone's, something will happen in this class, you guys will ask me a question, I'll be like, I don't know, I've never thought of that before. And then that would be an opportunity for us to look, to continue that process. And second of all is because I can't stand not knowing things. You know, that's the other reason. So when I read something, I'm like, I have to make sense of this, which can make life very frustrating. But you know, that's kind of. And then to kind of compare and contrast this with PCK2, next when you take during block 2, is that PCK2, instead of analyzing concepts, we analyze problems. So in a way, well, I don't know which ones. Some of you will like the problems better than the concepts, and some will like the concepts here. But yeah, so that's kind of how I delineate them. We look at cons because I like to make sure we understand some concept before we actually look at problems. Okay, for right now, let's go ahead and open up the course packet. Go ahead and look at table of contents real quick after the syllabus and a very, well, tentative day schedule. We tend to stay pretty much on schedule in here with that. And then a couple things, the first concept analysis, you see parallelism on page 17. And then I do have a problem analysis just to show you how we will compare and contrast the two. And then we won't really do any more problems. It will be after that. There's some interesting concepts there, and I've got some we'll pick and, well, we'll probably get over all of those and do some other things down there below as well. Look at the syllabus. This is not a rocket science course, but again, it's, most of you will walk away saying, you know, these are the classes that you go out and you get to, or that help you go out and show like cooperating teachers in the field, like, you know your crap, because you know, you dig into concepts so deeply that I promise you that most math teachers have not, okay? Because I talk to them and they ask me questions like this. And this was a seasoned student or a seasoned teacher asked me this. This has probably been 10 years ago now, right? And asked me, where's the plus minus come from? That was a great question. Right? I mean, we say this, we'll take the square root of both sides, okay? And we say things like, and I'm not going to answer this question right now, but we say things like, well, the square root of x squared is x, and you just lied right there because the square root of x squared is not x. Okay, I know you think it is. Ryan's like, no, I gotta go look that one up tonight. and we say this, the square root of 16 is plus or minus 4. Well, that one's obvious. The square root of, well, I don't think it's so obvious. Because for test number 3 in your pre-algebra class, I'm making crap up. Test number 3 in your pre-algebra class, question number 14, asked this, square root of 16, and you wanted the answer what? You only wanted 4. You did not want plus minus 4. 4. Because that symbol is a special symbol. And that symbol does mean just give me the positive one. Or give me the principal one. So then, but then here's the thing. We say the square root of 16 is just 4, and I'm not going to sit here and say that I didn't know this coming out of my undergraduate career, so I'm giving you more. You should be smarter than me. Because when I first started teaching, here's what I answered. When the student said, well, where's the plus and minus come from? Here's how I answered. I said, well, if you're just asked what the square root of 16 is, it's 4. If it's inside an equation, it's plus minus 4. That's a stupid answer. It's not even right. Okay? But it's what most teachers say. Well, if you're doing it inside an equation, you just put the plus minus 4 there. Well, I mean, that's true, but it doesn't answer why. It doesn't answer why at all. We'll get to that because that one's down there. Oh man, where is that? Number 47, page 47. We got a long way to go. Okay. What's that?
It's like the suspense.
I know, man. It'll be like May 3rd. You'll be like, oh, I gotta get to it. Whoa. That's all right.
You gotta get to that.
It's the key.
Right,
Keep it.
Yeah, it's the key. Well, it's the key from last year. I might have changed, the answers might have changed. Anyway, there's my normal information stuff. Catalog description. This is really just a partial review. It's a review of the math taught in secondary schools. It's what you want, right? Because you haven't solved the quadratic equation in years. You've been trying to figure out what a group is, right? And all that stuff. Anyway, I'm not going to read all this crap because it's boring. if as far as evaluations, just participate, share. When I say, what'd you work on? What are you thinking about from that problem last night? Don't say, oh, I didn't get to it. Spend some time on it. Okay? Spend an hour between Tuesday and Thursday. You don't have to spend 2 hours, 3 hours. The problem with this course is that it can consume your life. Okay? PCK2 more than 1 because PCK2 is about problems. And problems sometimes frustrate us, right? And we have to solve that. And what I tell people is, don't not do your linear algebra homework because you got caught, for 3 hours on an interesting concept here. Work your hour and say, now I'm going to see what Steve has to say about that next class period. And then after you want to work a little bit more, maybe work a little bit more, and then do your flipping linear algebra work. Okay. Do not neglect. I just cut myself on that when I flung that. Now I'm bleeding all over my page. Right? Dang, that's disgusting. All right. Anyway, attendance, just like all the other seminars, you get 1 unexcused absence. But please don't miss because there's only 4 of you. And we'll miss you if you're gone. And 2 people are gone.
Junior skip day.
What's that?
I said junior skip day.
Yeah. We don't have those. Anyway. Okay. So I'll ask you if you have any questions on the syllabus on Thursday, so you can sign later. All right, page 13. I told you you're going to walk away knowing the 3 actions for teaching, right? What are they? Know your content, know your crap, know more than your crap, and teach from the overload of crap. Okay? That doesn't sound very good. So, we'll rephrase that. Know the content that you're going to present, but know more than the content you're going to present. And now, careful with number 3. It doesn't say teach the content that you're going to, or teach the overflow of the content. You don't teach the overflow. It says teach from the overflow. You always know more than you're giving your students. Your students couldn't handle all that you know. Okay? Hopefully not. You couldn't handle all you know. No. But you don't teach the overflow. You teach from the overflow. I know a little bit more, but I'm not telling you everything because you can't handle it yet. Now maybe by the end you'll know more, I'll have taught you everything that I know. But there's that's why you take linear algebra and modern algebra and number theory and that. You think of your number theory class last year. I'm trying not to think of it, right? You think of your number theory class last year, and you may never do anything with modular arithmetic, again, right? And you did do something like that last year, right? Yeah. Okay. you may never think about it, but having that knowledge of the remainders and the equivalent, that right there should help us teach just anything to do with numbers, theory of numbers, equations, things like that. All right, let's go ahead and read through these because I want us to know what is meant. What do I mean when I say pedagogical content? Because think about the words, right? Titles mean something. It's pedagogical content knowledge. So it's content knowledge that should inform our pedagogy. And what's pedagogy mean? Fancy word for the science of teaching, right? The methods that we use for teaching. What types of pedagogy did you use? What kind of methods did you use? It's one of those secretive educational words, okay? Nobody on the news is ever going to say the word pedagogy at all, okay? You're never going to hear it in a movie. Yeah, I promise you. Who's your favorite actor? I don't know. Who are our famous actors now? I don't know. I don't watch movies. I came from the Harrison Ford days. Bruce Willis, these guys. They're never going to say, he's never going to say, you've all seen Die Hard, right? Yeah, what was his famous phrase there? What was it? What was it when he was going to let the guy go, or he was going to kill the guy? Hasta la vista, baby. Right? He said that, and
sure.
He's never going to say, and watch my pedagogy. There. He's never going to say, watch my method of teaching you anything. So, anyway, all right. It's one of those secret words. Ryan, read number 1. What is meant by pedagogical content knowledge?
The concept of PCK is not new. The term gained renewed emphasis with Lee Shulman, 1986.
The year I graduated from high school.
Oh, really? Nice. A teacher education researcher who was interested in expanding and improving knowledge on teaching and teacher preparation that, in his view, ignored questions dealing with the content of the lessons taught. He argued that developing general pedagogical skills was insufficient for preparing content teachers, as was education that stressed only content knowledge. In his view, the key to distinguishing the knowledge base of teaching rested at the intersection of content and pedagogy.
Okay, so, yes, 1986. So, understand what Shulman did here, okay? So, he was trying to improve the knowledge on teaching and teacher preparation. That when he looked at teacher preparation, it completely ignored questions dealing with the content of the lesson taught. Okay? What I mean is, like, the specific mathematics taught. Like, there were pedagogical strategies and there was mathematics, but the content of the lessons taught. Okay? People back then were taking general pedagogy classes and then still always taking your math classes, but there was no intersection of the two. That's why you take a math methods course and we teach you how to teach mathematics, not just how to teach. Now there's general how to teach stuff too, but I'm more concerned with how to teach math, and then those general strategies are in there as well too. So he was really talking about intersecting content and pedagogy. Right? And actually my PhD dissertation was actually on the merging of content and pedagogy. So this kind of near to my heart, I guess. Cody, read number 2.
Shulman defined PCK as teachers' interpretations and transformations of subject matter knowledge in the context of facilitating student learning. He further proposed several key elements of PCK. 1. Knowledge of representations of subject matter, or content knowledge. 2. Understanding of students' conceptions of the subject and the learning and teaching implications that were associated with the specific subject matter. And 3. General pedagogical knowledge for teaching strategies. To complete what he called the knowledge base for teaching, he included other elements. 4. Curriculum knowledge. 5. Knowledge of educational context. And 6. Knowledge of the purposes of education.
Okay, let's pick these things apart here, okay? So, several elements of PCK. First one is a knowledge of the representations of subject matter. So, it's not just knowledge of content knowledge, not just knowledge of your content or content knowledge. It says it's knowledge of representations of a subject. We need to think about all the ways we can represent our content. It might be graphical, it might be through definitions, procedures, whatever. I don't want to give away, I guess, we've really already mentioned these even in history of math even. But the first thing I'm going to look at I guess it won't be until next week, but like the square numbers, well, I don't want to say that because you don't know them by the term square numbers. You know them as perfect squares. Okay, 36, 25, 49. But the question is, we only represent them as a square root symbol 36, and we say it's 6. And we say, why is 36 called a perfect square? We answer that with algebra, because it's square root is what? And what kind of a number? Yes, it's 6 times 6, but what kind of number? It's a whole number, right? Well, but why the term square? Why can't you just, right? You get it? Why can't you just call it a green number? Why is it a perfect green number? Because when you take that green root of it, that's what you're really saying. The green root of it, why can't we color code everything? Some of you highlighters. You're a highlighter, aren't you? You are. You got highlighter. Because the green root, I like squat. I know these two don't. I underline everything. The green root, you guys have to intermix or something. The green root of 36 is 6. Okay, well, so what? What's square got to do with it? Well, because there's a representation, right? And we talked about this before in other venues, I think. There's a representation of it. Square. It makes a square. 6 by 6 is square. Why is it 25? Why is it 24? A perfect square. Well, because you have to build a 6 by 4 rectangle. an 8x3 rectangle. There's no whole number, right? Because there might be a 2, not in this case, but there might be a 2.5 that gets you to something, or 3.78 or something. But to get 24, there's no whole number that you just build a square with. Well, okay. So there's another representation for it. And we'll delve into that a bit more. Well, anyway, that's knowledge of representation. 2, understanding of students' conceptions of the subject matter and the learning and teaching implications that were associated with the specific subject matter. So the second part of that is, I need to figure out how my students are thinking about it. Because I can guarantee this, your students that aren't math people are hearing you say perfect square number. And they're hearing the word, because it's not a perfect square, because draw a non-perfect square up on the board. There's no such thing as a non-perfect. It's a square or it's not a square. Perfect square, it's a stupid name. Every textbook says perfect square. Past 1950. Before that, there were square numbers. Okay? Square numbers. If you have an old encyclopedia or an old math dictionary, they're just square numbers, not perfect squares. But my point is, when a student hears, that's a square number. They're visualizing square, and you ain't saying nothing about a square. You're saying, well, it's equals 6, a whole number. Well, where's square come from? And then you say something stupid like, well, because that symbol is called the square root. Well, why is the symbol called square root? Because if you square, oh, now you're just talking around your butt, right? You know, your circular reasoning there. It's called a square root because if you take the square, or it's called a perfect square because if you take the square root, you get a number 6. Well, then why is 6 to the second power called squaring? Because when you square it, you get a perfect square. You're just going around in circles. Okay? There's a reason why it's called a square number, dang it. All right? So, what's students' conceptions of it? Student wants to divide. When you're dividing fractions, now because you don't think about this because you've been corrupted with math. Okay? Back in the old days, when I say old days, I'm talking like 1500s. Okay? It was said that you're reading history of math, right? All these people who discovered crap, and they're all like 18 years old. You think, how the heck they do that? 23 years old, then they didn't do anything else with their life in math. Well, why did they do anything with their life in math? Easy answer to that. Creativity is gone by the time you're old. Creativity is gone. And it's even worse for you because we've corrupted you with this formal education crap. So we don't want you to, create. Because my 5th grade son can solve problems that I can't solve. Because he looks at it, he's like, well, yeah, that makes sense that you just do this. And I'm like, I'm trying to write an equation. Right? I'm making a system of equations for it. And then I got to use my algebra. He didn't know any of that crap. He's just like, well, if you just look at it that way and do that, the answer's 5. I'm like, how'd you figure that out? So you lose creativity by the time you're like, well, really it's 30, they say, so I'm kidding, should give you a little credit. You lose your mathematical creativity by the time you're 30, and then you know what they say? They say, that's why people in their 40s and 50s, I turned 50 in May, the people in their 40s and 50s, they go into teaching. Because they're done being a mathematician. Now though, you can't make a living being you can, but for most of us don't want to make a living by just being a mathematician working for an outside agency or whatever. So we go into teaching early, but that's just because of the way the educational system is set up in the world now. But anyway, understanding the student's conception, like how do they look at this stuff? Third thing is general pedagogical knowledge. Well, you need general stuff. And then he adds to that curriculum knowledge. You're not going to gain curriculum knowledge until you've taught through an Algebra 2 curriculum, pre-algebra curriculum, 8th grade math curriculum, a couple years. Okay, you're just not going to know it. But some things should start to click. One of the student teachers, and again, his co-op, been teaching for 10 years. Okay, he tells me that, how do you say that? He said before Christmas, they learned how to complete the square, to solve some quadratics. Now, these people aren't using books anymore, right? They're just randomly doing worksheets and all this crap. So it's like, nothing is clear and coherent, like a textbook. Read a freaking textbook, okay? So he does completing the square before Christmas. It was like a couple weeks ago. So we're in end of February, and he tells me that they're getting ready to do the quadratic formula, whatever. And I said, I said, okay, well, I'm assuming right before that, you've done completing the square, because whether you remember or not is you get the quadratic formula from completing the square, and we'll get to that too, but completing the square on a general quadratic equation. Well, I said, well, then I'm assuming like last week you used completing the square technique. And he said, oh no, that was done before Christmas, before I got here. And I said, the heck did you use completing the square for? Completing the square, and then you stop curriculum, you should be then using completing the square to derive the quadratic formula. People all over the place, like, why are things the way they are in a textbook? Figure it out. I still remember my first year of teaching, I still have a textbook. I stole it. No, we adopted new textbooks and I took one. That's on video. I stole it? No. Sorry, 71st High School. Anyway, that was the name of my first high school, 71st. Who names their school numbers?
First 70 were taken.
Exactly. Right beside it was 70. It was in between. 70 and 72. But anyway, so you know too much alike.
That's scary.
What was I saying? Oh yeah, first book. I remember this. I was like, I loved it because solving systems of equations. Think of a system of linear equations, right? What do? First, we graph it. Why do we graph it first? We get that visual of two lines intersecting, right? And then we go to substitution. Okay, we substitute one in. We solve one for like y or x, and we plug it in, right? And then we go to the linear combination method, the linear algebra stuff, right? And solve it through whatever elimination method, addition method, whatever you want to call it. But then, for me, because I love my linear algebra courses, and for me, my next step was solve the system by matrices. Now, you don't do that anymore because matrices aren't part of the Keystone exams. Okay, so they've chucked those to the back of the book, or actually they're just taking out of the book. So that way, I'm assuming that how many people jumped in their linear algebra class and never saw a matrix before? Yeah, you saw one. You saw
one once before. I think Jim.
Oh, Jim. Okay, but in high school, you never saw, right? Now, your linear algebra teachers here, most of us assume. I mean, I don't, but because I know a little bit better. But most of them assume that you know something about matrices. Well, anyway, the point is that the textbook I used went from elimination method to introducing matrices and used that to solve systems. That was great because that was my understanding of the curriculum. Well, then we adopted new textbooks. Yeah, I have that one too.
I see a trend.
I still love textbooks. I love textbooks. So I got this new textbook, and the new textbook had whatever, chapter 5, I think it was. Chapter 5 was solving system equations. Matrices were in chapter 13. Well, there's story, and there's nothing wrong with it. It was just a different story. You just have to understand the story of the curriculum. The story was just that. That was the solving of those, and then later you did what we do after, probably polynomial stuff. But anyway, then you jumped into polynomials, then you introduced matrices later on. No big deal, it's just a different story. Understand the curriculum. And then educational context and purpose of education. Number 3. Oh my gosh, Jessica.
PCK.
I was going to Jennifer.
That wasn't even close.
Yeah.
PCK is the knowledge needed to make subject matter accessible to students. There are 2 core aspects of this knowledge. Knowledge of students' subject-specific conceptions and misconceptions, as well as knowledge of subject-specific teaching strategies and representation.
And I kind of read that, or explained that before. Go ahead, Ashley. Go on.
Alright, definition. PCK is a special combination of content and pedagogy that is uniquely constructed by teachers, and thus is the special form of an educator's professional knowing and understanding.
I'll read the next definition. PCK, also known as craft knowledge. It comprises integrated knowledge representing teachers' accumulated wisdom with respect to their teaching practice, pedagogy, students, subject matter, and the curriculum. So it's accumulated wisdom. You are not going to walk out of here having the PCK, the pedagogical content knowledge that I have. I've got 26 years experience with students and studying the subject, okay? It's accumulated. It will increase as time goes, though. Ryan, 6.
PCK is deeply rooted in a teacher's everyday work. It encompasses both theory learned during teacher preparation as well as experiences gained from ongoing schooling activities.
Yeah, it's ongoing there. Go ahead, Jordan.
PCK illustrates how the subject matter of a particular discipline is transformed for communication with learners. It includes recognition of what makes specific topics difficult to learn, the conceptions students bring to the learning of these concepts, and teaching strategies tailored to this specific teaching situation.
So it's about how a particular subject matter is supposed to be transformed to communication with learners. So, and I know you got to eventually get out of the I'm sitting in college classrooms, because you're about to be put into 7 through 12 classrooms, and those learners are different than adult learners, and certainly the teachers are different. So as much as we would like to think, and they're not necessarily supposed to, so you got to give them some break, I guess, is that college professors, most of them, do not sit down and say, I have to teach this subject matter today. How do I communicate this with my students? They look at that and they say, I'm just going to tell them what it is. Okay, you know what I'm saying? Some may read it out of a textbook. Some may just write down the examples that are in there. Some may just ramble about crap. Okay? But you're being trained to be secondary teachers, and we're going to communicate with adolescents, which is a little bit different, but communicate with anybody ought to say, sit down and say, okay, it's craft. As much as I hate arts and crafts, I know you do too. You might be a little artsy. No. But I know Cody's not. As much as I hate arts and crafts, I love putting the pieces of a lesson together and saying, how can I put, oh no, I gotta say that first. Most people don't think about, I gotta say that first or second, or that's not gonna make sense if I don't put that there. Okay? Spend a lot of time doing it, and that's my craft. That's my making something beautiful of mathematics. G.H. Hardy said, there's no place in this world for ugly mathematics. Okay? It needs to fit together and be beautiful. Jessica, finish it up.
We must help our students either assimilate or accommodate the knowledge we provide them.
Remember those words from before. You're going to assimilate it or accommodate. If it doesn't make sense, we find ways to accommodate it. So what is meant by, when I say, so that's what PCK is. What is meant by an advanced perspective? Well, the first thing is it's not just surface level. Okay? It's not just, and for the most part, you gain a surface level by looking at, well, in this case now, the worksheet that you're giving, or the standard that you have to teach, or possibly even the one textbook that you're using, and there's the definition, and there's an example. I'd say that's really just a surface level. If you look at the stuff in the boxes, right, and then the examples. Most people forget. Now, it doesn't mean the textbook doesn't have some deeper level, because most people refuse. This is why I hate when college teachers use like algebra or like a calculus, like a manual like this. Even though, like Jim, when he taught, you guys all have me for geometry. I used to give him a hard time about, he used his own manual for geometry. I'm like, but when do the students read? And I know you don't read anyway your textbooks, right? But you should. But when do you read like a good, clear, concise, edited explanation of what you're teaching? Read your textbooks, okay? Especially the ones you're teaching out of, and have your students read them. That's where you're going to get some deeper knowledge. And then where am I going to gain even deeper knowledge? I'm going to read another textbook on it. And when I say, how many words are in section 3.7 in your algebra book? Maybe 2 paragraphs of words. Most of it is definitions, examples, right? It's 2 paragraphs, but there's good crap in there. Okay, there's good stuff in there. I promise you. And we'll run into one of these things later with the fact that when you write area, right? Everybody will write IN with a little 2 up there, and you'll read it inches squared, won't you? And that's wrong, because you didn't read your textbook. Because the textbook's not wrong. You're wrong. Every math teacher's wrong. Not everyone. There's a couple of us that say it right. It's not inches squared. I don't ever want to hear you read that centimeter squared again. It's square centimeters. Okay? And your textbook said it right, because in the words that you refused to read, it said, but now the problem is it only said it one time. It said, area is measured in square units. That's what it said. It says area is measured in square units. And then after that, it only gives you square units. The units are centimeters, square centimeters. But then you think it's a symbol. or I'm sorry, you think it's an actual like value. It's not a value, it's simple. cm2 is not x squared. Cm is not a variable. You don't read it as x squared, it's simple. And the whole thing means square centimeters. Okay? And math teachers are the only people who get that wrong, by the way. If you go to Lowe's and look at the paint container, it says this gallon will paint 300 square feet. And if you say, I'm looking for something that'll paint 300 centimeters squared to the associate, he's gonna be like, 300 what? I'm a math teacher, I know what I'm talking about. 300 centimeters squared. And he's gonna say, shut up, you don't know what you're talking about. It takes into account the many interconnections among math topics, takes into account the multiple representations, takes into account relationships to college level math. It includes a deeper, and so the question there is, like, how can this relate to what I know from modern algebra, from linear, from Calc 3? Not everything will, but is there something that I can? It includes a deeper analysis of problems and concepts in order to reveal important new mathematical insights and understanding. It's being mindful of the historical and conceptual evolution of mathematical theory and school mathematics. Remember my old textbooks that I've shown you guys before? For this first concept here, I wanted to look too. What's the definition of parallel in a book from 1916? Did it change? How's it different? What kind of applications do they use? So the goal of this perspective is to encourage you to explore mathematical ideas in depth, to explain mathematical ideas with clarity and precision, so you can develop what's called a profound understanding of fundamental mathematics. Understand what that phrase means. It's a profound understanding of fundamental mathematics. Not that I don't care that you know Calc 3 or real analysis or linear algebra. I want you to. But it's a profound understanding of fundamental mathematics. What I really want you to do, what's really gonna enhance your teaching more is if you understand proportions. Like nobody understands proportions in this entire world. And what to do with it. Least common multiple. Can you find least common multiple of 2? Sure. But do you know really what least common multiple is and how to build it up from? No, I'm going to say you don't know everything there is to know about least common multiple. But you can find least common multiples. We'll get to that too. This will hopefully help you develop a deeper understanding of secondary math and give it a new appreciation of its beauty, its logical structure, and its applicability. And the backbone of this perspective is a concept analysis and a problem analysis. This is about concept analysis. So look over here real quick because I got to go pretty soon. First concept analysis is this. So when you do a concept analysis, you don't necessarily do all of these things, and you don't necessarily do all of them in order. You do some to, half-butted. You do some, and some you don't do at all. But this is what you kind of look at. So it involves examining a concept so much and from so many perspectives that you feel like you never knew before. Like I want you to walk out of parallelism, study parallelism on your own for an hour maybe, between now and Thursday, and then our discussion on Thursday. And I want you to say, oh yeah, now I know parallel. What parallel is. Trace the origins of a concept. Okay? Maybe there's some historical aspects to it, maybe not. It might not be all that fascinating. Trace the applications. Hey, where's this used? Okay, so today I'm going to show my students or tell my students the definition of parallel, but I'm not going to teach it to them, but my overflow of knowledge, I want to understand the applications of it, things like that. Examine multiple representations of a concept, look at how the concept appears both within and outside mathematics, examine various definitions used to describe it. So, and my second note there, many times a concept analysis is predicated on a question that one is asking or has been asked, usually by a student that gets you thinking. Most of these things have been by a student that's got me thinking. So the first question really is a line parallel to itself? So I looked at that question, I was like, well, if you look at it this way, it is. If you look at it this way, it's not. So which one is it? And then I picked apart the concept of parallelism. So I've given you some things to consider. Again, some things might be left blank, that's fine. This is for our time on Thursday as well. But for now, go find some definitions of parallelism. What are some applications of parallelism? Answer as much as you can there. There's some deeper questions there. Hey, you ever thought that first deeper question? Are parallel streets really parallel? Well, they might look like it on a map, but you're sitting here walking around on a globe, aren't you? If those streets in a city were extended, right? Will they be parallel all the way around? Will they meet at the North Pole? I don't know.
Sometimes.
You know, maybe, right? So think about some of those questions there. Can a line be parallel to a plane? I don't know. Curves? You ever think of parallel curves? Well, maybe depending on some of your definitions. I don't know. We'll see what happens. Well, anyway, so closure. Remember, 3 axioms of teaching. We're going to know our content. We're going to know more on our content. We're going to teach from the overflow of our knowledge. And pedagogical content and knowledge is essential for secondary math teachers to have in order to create and implement high-quality learning experiences. And now that you've come this far in secondary math program, you've got enough math knowledge that you can, maturity hopefully, that you can begin to examine the math content at a deeper level. So. All right, you got your little work there. I gotta get out of here down the hall.
What?